this. Now, in this session, I would like to discuss on catalysis. That is another part of surface chemistry. What is catalyst? What is catalysis? It is interesting one. See, there are some reactions which are very slow, even after maintaining the external conditions such as temperature, pressure or concentration of reactants, etc., favorably. In such cases, to enhance the rate of reaction, to increase the rate of reaction, some foreign substances are used. Foreign substances in the sense other than the reactants. To increase the rate of reaction, which are very slow under normal condition, some substances are used. Such substances which are used to increase the rate of reaction are known as catalysts. Catalyst. Generally, catalyst is used to increase the rate of reaction. But nowadays, catalyst is defined as it is a substance which alters the rate of reaction. Sometimes some reactions are very fast. To reduce the rate of such reaction, decrease the rate of such reaction, some substances are used. They are also known as catalysts. So, catalysts are the substances which alter the rate of reaction, change the rate of reaction without undergoing any change in composition or mass, known as catalysts. Catalysts are the substances which change or alter the rate of reaction without undergoing any chemical change or any composition or mass. See, reactions in which catalyst is used is known as catalytic reaction or catalysis. Actually, in this chapter, we use some terms. Of course, first one is catalyst, catalysis, positive catalyst, negative catalyst, promoters, catalytic poison, autocatalysts, induced catalyst. Now, let us see the meaning of these terms. Catalyst, it is a substance which alters the rate of reaction without change in its composition or mass. Then, reaction in which catalyst used is known as catalysis. Next, positive catalyst. What is positive catalyst? Positive catalyst is a substance which increases the rate of reaction. The substance which increases the rate of reaction, which enhances the rate of reaction, is known as positive catalyst. Give an example for this. So, in the laboratory, oxygen gas is prepared. Generally, in the laboratory, oxygen gas is prepared by heating potassium chlorate. On heating potassium chlorate, it decomposes to give potassium chloride and oxygen. This is the reaction used to prepare oxygen in the laboratory. If you use only potassium chlorate for the preparation. The rate of thermal decomposition of potassium chlorate is very low. It slowly decomposes. So the rate of formation of oxygen during this process is very, very slow. To increase the rate of decomposition of this potassium chlorate, sometimes we use a substance known as manganese dioxide, MnO2. If you use a little amount of MnO2 with potassium chlorate for decomposition, then the rate of decomposition of potassium chlorate is very high. More and more amount of oxygen will be formed in a short interval of time. Here, manganese dioxide increases the rate of thermal decomposition of potassium chlorate. Hence, manganese dioxide is positive catalyst. Just keep it in mind. Example kelbodu. Give an example for positive catalyst. If you write simply MnO2, you will not get mark. No doubt MnO2 is a catalyst. In which reaction it acts as catalyst? That you have to mention. Manganese dioxide acts as positive catalyst in the decomposition of potassium chlorate, that is thermal decomposition of potassium chlorate. This thing required. Next, negative catalyst. Negative catalyst, they are the substances which decrease the rate of reaction. Some reactions are very fast. Some reactions are very fast. To control such reaction, to reduce the rate of such reaction, sometimes some substances are added into the reaction mixture. Such substances are known as negative catalysts or inhibitors or retarders. See, H2O2, hydrogen peroxide, easily decomposes. Even at ordinary temperature, it undergoes decomposition. So, it decomposes to give H2O and O2. This decomposition of hydrogen peroxide can be reduced by adding a little amount of negative catalyst. See, in this case, phosphate group acts as negative catalyst. Any phosphate acts as negative catalyst. Even little amount of sulfuric acid acts as negative catalyst for the decomposition of hydrogen peroxide. Sometimes hydrogen peroxide is mixed with chloroform, carbon tetrachloride, etc. to reduce its thermal decomposition. So here, phosphate group acts as negative catalyst in the decomposition of hydrogen peroxide into H2O and O2. Next one, promoter. What are promoters? See, some catalytic reactions are not fast as we expected, even though catalyst used in the reaction. In such cases, some substances are used to increase the activity of catalyst. As the result, the rate of catalytic reaction increases considerably. Rate of catalytic reaction increases considerably. So, the substances which increase the activity of catalyst, which in turn increase the rate of reaction, known as promoters, catalytic promoters. See, in the reaction of synthesis of ammonia by Haber's method. Iron is used as catalyst. Iron is used as catalyst. See here, to increase the activity of iron, another substance is used, that is molybdenum, which acts as promoter. See, give an example for promoter andre. If you write molybdenum acts as promoter andre marks kodalla. Even in the case of conversion of methane, of course oxidation of methane to form methyl alcohol, zinc oxide and chromium trioxide are used. See here, molybdenum acts as promoter to iron catalyst. Here zinc oxide acts as catalyst, it is promoter. Molybdenum acts as catalyst for the promoter for the catalyst iron in the synthesis of ammonia by Haber's method. Give an example for promoter andre molybdenum and baradre kodalla, don't get the marks. We are supposed to write molybdenum acts as catalytic promoter for the catalyst iron in the synthesis of, in which reaction you have to mention, in the synthesis of ammonia by Haber's method. That is. Next one is catalytic poison. See, in some catalytic reaction, sometimes some substances are present as an impurity and decreases the activity of catalyst. As a consequence, the rate of catalytic reaction decreases considerably. In some chemical reactions, catalytic reactions, sometimes some substances present as impurities which decrease the activity of catalyst and consequently the rate of reaction decrease considerably. See, in the synthesis of sulfur trioxide by the oxidation of sulfur dioxide in the contact process, ruhenium or platinum, palladium used as catalyst. In this case, palladium is used as catalyst, sometimes platinum is also used, platinized asbestos is used. Here, if any arsenic substance, As2O3, arsenic or arsenic oxide present in the reaction mixture, it considerably decreases the rate of this catalytic reaction because it is catalytic poison for the catalyst palladium in the oxidation of sulfur dioxide process or contact process of production of sulfuric acid. So, arsenic oxide acts as catalytic poison. See, promoters increase the activity of catalyst, poisons decrease the activity of catalyst. How? That's the question. See, catalytic promoters increases the active centers of catalyst, increases the surface area of catalyst. As the result, more and more amount of reactant molecules collect on the surface of catalyst and converted into product, thereby increase of rate of reaction. So, promoters increases the active centers or surface area of catalyst, consequently increases the rate of reaction. What about catalytic poisons? Catalytic poisons decreases the activity of catalyst. Catalytic poison decrease the activity of catalyst. That is, catalytic poison decreases the active centers of the catalyst. Decrease the active centers of catalyst. That is, catalytic poisons get absorbed on catalyst, surface of catalyst, in preference to reactants. As the result, reactant molecules do not get the space to absorb or to undergo reaction. This is the reason how catalytic poison decrease the activity of catalyst and promoters increase the activity of catalyst. Next one, autocatalysis or catalysis. See, it is observed some reactions are very slow in the beginning. Some reactions are very slow in the beginning, but after few minutes, the rate of reaction considerably increases. The rate of some non-catalytic reactions are very slow, very low in the beginning, but after time the rate shoots up, increases considerably. I'll give an example for this one. You just say this reaction, CH3COO CH3. It is an ester. Of course, methyl acetate. Methyl acetate. Generally, hydrolysis of ester is carried out by using acid catalyst. By using an acid as catalyst. See, if you won't use acid catalyst, the hydrolytic reaction of this ester can be written as CH3COOH plus CH3OH. This is the reaction. See, in this case there is no catalyst. If you won't use the catalyst in this reaction, hydrolytic reaction, the reaction of this ester, the hydrolysis of this ester is very, very slow in the beginning, of course. After some time, the reaction considerably increases. Reason is very simple. One of the product here, one of the products, say acetic acid formed in this case, itself acts as catalyst. In this reaction, there is no special catalyst for it. We have not used any special catalyst. But during the reaction, in the beginning, reaction is very slow. After certain time, the rate is considerably increased. It is due to the reason one of the products formed acts as catalyst. In this case, this product, acetic acid, that is acid formed, acts as catalyst and enhance the rate of reaction. This type of reactions are known as autocatalysis. And the product which acts as catalyst in such reaction is known as autocatalyst. Next one is induced catalyst. It is another interesting term. Say Na2NaSO2, sodium Na2SO2, sodium arsenate, sodium sulfite, sodium sulfite. sodium sulfide easily undergo oxidation to form sodium sulfate. Even on exposing to air, sodium sulfite absorbs oxygen, captures oxygen from air or atmosphere to convert into sodium sulfate. Whereas this one does not undergo this type of reaction, oxidation. Sodium arsenite does not undergo oxidation. On the other hand, if you mix sodium arsenite with sodium sulfite and expose to air, both undergo oxidation. Both undergo oxidation. It is interesting one. So, in presence of this reaction will also take place. So, it is also oxidized to Na2SO3, sodium arsenate. Okay. This type of reactions are known as induced catalysis. Here, this reaction induces this reaction to undergo. Otherwise, as such, this reaction does not take place. This is about that important terms come in the catalysis. Next, we shall see types of catalysis.